Yeah.
Thanks for joining. Start this recording. This may go to YouTube as well. So be careful whatever you're asking. Everything will go to
Okay.
YouTube as well. Anyways, you can ask any question, and if you have some private thing to discuss, then you just raise your hand. So I will pause the recording, and then you can ask those things as well. So there is no problem. I'm recording this video
Okay.
because we have, I think, 5 to 6 students, and I can see only 2 have joined today. So they can watch
Mhm.
the recording, and even I also prefer whenever I'm getting some online trainings and all. I used to prefer that recorded video as well because sometimes we are getting some calls, we are checking our WhatsApp message and all those things. I also used to do those things while getting such type of trainings, this online trainings and all. This live training is something different and online is different, but we can't do these things like because people are in different areas, so it's very difficult. But it's still that classroom training is very difficult to match. Classroom training is something that 1 hour classroom training is really good. That if you have much doubts, you can directly ask. Teachers can interact with you directly. With their confidence, you can also get some confidence. Like those things are there. Anyways, so let's
Mhm.
just start the training. You can see the agenda for training. This training, basically, this batch is for those students who are preparing for CCI, mostly CCI Enterprise. So I'm going to cover those portions as well. That is the agenda within the CCI Enterprise SD-WAN. And apart from that, you can see that normal things are also there. Normal things like SD-WAN curriculum is also there, such as basics of SD-WAN, how to configure it via template, the protocols used in SD-WAN, the policies in SD-WAN, and some advanced policies option as well. So overall, I'm going to cover the concepts of SD-WAN and how to use it. And this is going to be, you can say day 15, means 15 sessions, but these classes are something like boiled together. So 2 days are boiled together in one session. That means I'm going to complete these sessions within 8 classes. Okay, 7 to 8. Maybe 8 classes I will take. So I will cover these policies step by step. So you will also understand. So I'll go and take time here in this section when we'll reach to policy section because that is the critical part we have in Cisco SD-WAN. So what I'm going to cover today is nothing but this day 1 and day 2 introduction to the program, and then SD-WAN introduction and different type of SD-WAN concept. And in the next session, whatever we will study, we will discuss for 10-15 minutes. I will ask you 1 or 2 basic things and then we'll proceed. So like that, day 1, day 2, then you can see day 3, day 4. Normal things like tomorrow we have class. So tomorrow we have some lab. Today we don't have any lab. Today I'm going to cover only the theory. But yes, tomorrow you can see that we have to go and check the vManage dashboard and we have to create CLI template. Few companies they are preferring the CLI template. Most of the companies they are using device template. It depends. Depend upon company to company. I know one company they have some 2000 VS devices. Even they haven't used Cisco CS devices. They told that they want to use Viptela devices. They have approx 2000 devices, and all those 2000 devices they are managing via CLI template. Okay, so it depends upon company, their thought process, how they want to manage their infra. And if they know that maybe some template having some issues, something is there with the feature template and those things, so they can go and manage by the CLI template.
One question, Ratnesh. The CLI template, why specifically we are calling it template? Do we require a special template for CLI access for VA, VH or CH, or by default it is available from vManage, or we require some template to configure on the device, then only it will be applicable.
Yeah, so what is definition of template? Some common practice, right? Some common practice that can be reused. So template you can think like because we are in AI and automation world, so you think template as a object. Okay. And if you have one object that you can reuse at different locations, so why not? So for example, if I go and create one template, and in that template I have variables, maybe 15, 20 variables I'm using. Now one template I can go and attach to 15 devices. And since I have variables, so all those 15 devices, when I'll go and attach those template to those devices, I will change the variable and I'll attach it. So template will go and first of all standardize the configuration, because one you have one standard template, and then with help of template you can reduce the overhead of creating the same common configuration, because everything is there in the template, and simply you will take it and you will go and paste it to the n number of devices. So that's the usability of template, and that's why templates are important, powerful.
Okay, got it.
All right. So what we'll study today is the program. So this is the program. So this part is check marked. This is that. Okay, we know that the program introduction. Uh, and then what about lab? You will get the lab. You need Cisco Any Connect to connect. I will show you tomorrow how to connect to the lab. And plus, even you can go and uh, work on your own, means you can go and reserve your own Cisco sandboxes. So that also I will show you, that you can go to developer.cisco.com, go to sandboxes.cisco.com, and there you can go and reserve your SD-WAN lab devices. They have very nice lab. Basically, they are presenting or giving those lab for automation purpose. The purpose is for automation, but you can also use it for your learning, for your SD-WAN learning. Then I'll go and introduce about Cisco SD-WAN and their components. So these three things I'm going to cover. So why not? Let's try to understand this. So let me go here and open my canvas. What was the first topic we have? That SD-WAN introduction and then the components. So let's start with SD-WAN introduction. Now, even to go and understand SD-WAN, if we go one step back and try to understand that what is Cisco SD-WAN, you know, uh, or even one step back, if we can go and if we discuss that what is SDN, what's the definition of SDN? What is SDN? SDN is what? What is this?
These are means Cisco's different tools and
Software defined network.
component
Software
software defined
defined
network
network.
that is used for managing the LAN network.
What is the definition of this? How we can define the definition of this?
I think it would be centrally managed with templates and
Templates, yes. Try.
yeah.
It is
And so,
generally
yeah.
decoupling the control and manage data plane. Means it is there is a
Yes.
control plane and data plane. So
Yes.
this
Moving the
is
control plane to a central point of
separate.
management.
Yeah. So in case of any failure or something happens, then it should not affect the environment immediately. You remove the device, attach with the controller, and paste all the control plane instruction, means commands, and you run it.
So you are telling it that uh, if you have one router, so let me try to draw one router. So if I have one router, and for that particular router, if I can go and divide, so suppose I have one router, and in this router, if I can go and segregate, what I can go and segregate the control plane and data plane. Suppose for this router, I have control plane, and for this router, I have data plane. So that will be the SDN, software defined network, that you're telling?
So,
No, the control plane is managed on a different level.
Decoupling of data plane and control plane. So control plane and data plane, right? That's the definition of the SDN, right? Software defined network.
yes.
That's a standard definition. Decoupling the control plane and data plane, right? So if we decouple the control plane and data plane, then what is the benefit? What's the benefit we have?
So all your control traffic, all your control stuff is managed centrally, and your data stuff is allowed to use the router itself. So you do not overload the router with control plane information tasks.
Okay. So
you move it to a central location.
So your point is this, let me go and make, so the decoupling of data and control plane, right? So your point is this, that if we decouple the control plane and data plane devices, right? So in that way, what will happen that if I have n number of devices, for example, right, suppose I have routers, router 1, 2, 3, and then I have decoupled. So then I have the controller somewhere who can take the decision, my controller, such as control plane. And in Cisco SD-WAN, control plane basically referring to routing intelligence. Okay. So VS Smart we have in Cisco SD-WAN that is there to do some routing intelligence. Okay. And then you have the data plane devices. Data plane devices means your C edge, V edge, the edge devices. So edge devices. So that means that you're telling that, okay, if you go and do such type of decouples, then you will not burden all the routers for their routing decision, although they can get connected with one centralized controllers, or maybe you have distributed controllers, so they can go and get connected. And once they are getting connected, so let me go and try to connect, say they have some connection here, and they have some connection. Later on, we'll discuss about this connectivity. So you have some routers, right? And what you have done as per standard practice, as per standard SDN practice, what you have done that you have decoupled. So your central intelligence is somewhere who can take the control or routing decisions, and then the data forwarding is somewhere. They are doing some data forwarding, right? But the intelligence, the brain is somewhere, right? So if we do such type of thing, like if we go and decouple the data plane and the control plane, what is the benefit? What is the benefit? Why we are doing it? So the first benefit here is this, that you are managing everything
Centrally.
centralized, yes. So you have now centralized system. That board of uh, what is the board of directors or board of managers, they will take decision, and then that decision will go to all the engineers. They are working at different locations. So that means that the policy makers are somewhere, sitting somewhere, and the implementers are somewhere. Policy makers will make the policy, and then via some encrypted tunnel, via some secure tunnel, they will push those communication to the implementers who are going to do the actual task, like carrying the payload and sending to other place, right? So in that way, what you are doing that you have your centralized, you know, centralized network. The other thing that you are doing that you are overloading the edge devices. Now they are tension free that, oh, once I'll get some information, I will do some tunnel change. I will do some routing change. I will do some topology change. I will do some hub and spoke, or I'll do branch to branch communication. Those type of things they will do once they will get instruction from the controller, right? So you're overloading the edge devices. Even normal devices can also work as a edge devices. Like your cost will get reduced. You don't need high CPU, high memory router. You need normal routers at the branches. So because they don't have to take routing decisions and all. What other benefit you have? You can centralize the network and you can overload these devices. Any other benefit you have?
Ease of management.
Ease of management. Great.
Almost zero touch.
Management. Okay. So zero
Less downtime.
How? How this
Because
work?
earlier what was happening that if any device started malfunctioning, so its task was to reconfigure that device and then attach it. Here there is a small script, just push it and mm, connect
Because
it to the
less downtime, because
No
why?
need for
Be-
highly skilled
Because
resources.
because you have template
yes,
somewhere, and then you have the controller somewhere, and then if device is down and it is completely down, it is like blackout or something, then you can reroute. For rerouting, you are not depending upon the local device. So
yes.
local device dependency is not there because we have centralized management, centralized inventory,
Mm.
centralized everything. So obviously the downtime will be less with compared to legacy thing, like everything is in one device, and if that device is down, all business will go down. You're right, yep.
Second thing, less dependency on field tech, because in
Filter.
this case, anyone from that side just go and
Yeah,
put
you
the
already mentioned is
device.
that
Yeah.
zero touch is there. So
Mm.
simply someone has to go and connect the interface and it will get all the configuration and all those things. Yes.
Yep.
Yeah, right. Yes, that's great. So good points. And even, some advanced things is also there, like, you can go and connect with, so there is one centralized controller as well called vManage. One component is vManage, and that can be integrated with APIs, right? And if you go and uh, integrate with API, for example, I'm using one tool, Notobot, that is from Network to Code company. And this is nice. I will show you that I can go and integrate with APIs, and from API I can instruct vManage, and then vManage instruct the controllers and edge devices, and things can happen from one API call as well. And even because we are in the AI world, AI innovations are possible. Right? So if you have some
Mm.
AI tool and something, you can directly connect to the devices, and from there you can go and integrate your what you can say, integrate your not only automation part, but you can do some more innovation like LLMs. Like uh, at the moment you need to learn something, that how to attach, deattach, how to do this, what are the steps to do this maintenance, what are the steps to do iOS upgrade and all. If you go and
Mm.
integrate with AI, then what you need to do, simply open chat box and tell, hey, do this for me, and behind the scene that AI will do. Like you need to give instruction like you are giving instruction in chat GPT, like that you can write it and it will do the task.
Okay.
You think that this is possible?
Yeah, currently, earlier what was happening, like for iOS upgrade, we were taking approach one by one and upgrading it. But here using DNAG, you can in a one go like 150 devices in one go. You can upgrade the device.
Okay, so what I'm telling that can I open my AI tool and I tell AI tool, hey, can you do this task for me? And can it will do that? That I'm asking.
No, you need to integrate it back into your management plane, right? So
Yeah.
you'll need to take what AI gives you.
Mhm,
You'll need to convert that with maybe netconf, resconf, whatever,
mhm.
Mhm.
and then put that back into your and then you could then send it back, right?
Okay, so maybe you heard about this tool cursor. Let's try. Okay, so cursor is started. Hi. Let's see. I'll go here.
Mhm.
Hi, can you connect to my vManage and give me device list? My vManage IP is and username password. Let's see. Okay, so it is giving some API.
Okay.
I'm not doing anything. I will simply tell okay. So maybe this got failed. So then it is giving other, oh, successful. Okay, perfect. Display devices. So see, these are the devices we have.
You are taking
Yes.
our jobs, Ratnesh.
So already they have taken, not my tool. Right, so these are the devices. So yeah, so in our, okay, so let's see one more thing. Can you draw topology? See our lab topology, how it will be. Let me create a comprehensive topology diagram. Okay, do it. Meanwhile, let me draw the topology. Let's go here, and in our lab we have these devices. So we manage. What's the use of we manage? It's like managing all the things. It can be integrated with APIs, from where you have all the configuration, all the policies, and from here you can actually manage the entire infra. Then you have the brain, VS Smart. These are smart devices. They are actually pairing with the edge devices, and they are the brain. So all the routing decisions and all those things they have to do. Policy, routing, IPsec tunnels, they have to manage. Then you have vBond. This is nothing but orchestration plane. If any device will connect or leave the fabric, is the responsibility of vBond. vBond will go and manage the entire fabric in and out. It's like authenticator, vBond. And then finally, who will do the actual task? So to do the actual task, you have these edge devices. Either it may be Viptela V Edge or it may be Cisco C Edge. These are the devices. They have IPsec tunnel in between them. Okay, so it has drawn something in text because I haven't integrated some drawing tool, but yes, I can integrate some drawing tool as well. And this is in text. So let's try to do that. Yeah, what is this? Tool.
So,
Just a second. Hmm?
what API you are using here?
Normal, we manage, they have APIs, right? They are API aware. So I'm not using any extra thing. Uh, this the API they have. We manage API. See, it is drawing the topology. So you can see the control plane, data plane, and you can see that this is exactly how our diagram look like. So you can see it is able to draw the topology as well. Okay, 1 second. Okay, so it has drawn the topology and oops, 1 second. Can I send this information to my? So I have one tool where I started trying all those things and all. That is
Mhm.
Obsidian. I haven't integrated with Obsidian, but I have the API key and the uh, local username and password. So let me provide this to this. 1 second, I need to give that API key. This is my Obsidian where I'm drawing and writing notes and all. So once it has generated those things, what I want to do, I want to send that notes to my Obsidian. This is my notes, but it is asking the API keys and all. So let me do one thing. Let me quickly copy and paste the API keys and pass it. So I should not, that's the problem, this API keys, because my API keys anyone can use. So that's why I want to integrate with MCP server. There is one concept, MCP server, so that they will hide the API keys and all. Anyways, I'll share that. Just a second. Let me quickly pass that information. Anyways, I'll change my API key after this class. Not publishing this anywhere at the moment. Before publishing this video, I will change my API key. Do not see my API key. It is. Okay, so yes, skip this and use API keys from my mcp.json file. So I have this file here. From there, it will go and use the API key. So let me see if it can do. Now creating comprehensive Obsidian node with SDWAN topology using your API credentials. Meanwhile, it is doing that. So let me quickly go and show you that this is our topology. So in our topology, we have the controllers, which is there. Assume that they are there uh, somewhere in the hosted in the cloud, and we have some internet circuits reaching to the controller. Then we have the data plane devices. We have DC1, VH1. I will also go and draw these diagrams. So let me quickly show you our diagram in our lab, little quick, and then we'll come back here. Continue presentation. So in this, if you go and see, yeah, this is our topology. So we have data center. Within that data center, we have DC1, VH1, DC1, VH2. Then we have two circuits, MPLS and Internet. And then we have branch 1 and branch 2. And then we have control plane devices. You can see here, we have two VS Smart, we have vBond, and we have one vManage. What about these connections and communications? I will cover in day number 2. Don't worry, I'm going to cover each and everything. So today agenda is simply to understand that what is SDN. SDN is nothing but decoupling of data plane and control plane, and why we are doing that decoupling. You know that. You have given nice examples. Then what are the components we have within the SD-WAN? Components we have actually 4 components, 3 controller components. vManage, that will do centralized management. vSmart, that is the brain, right? Then we have the vBond, that is the orchestration plane, which will check who is leaving, who is joining the fabric. It has all the references, it has all the information. And technically, we are telling this as a whitelist model. So vBond, they are working as a whitelist model. They have the serial number and chassis ID of the devices who are getting onboarded or even leaving the fabric, either joining the fabric or leaving the fabric. All those informations they have. But it's not like that only vBond has that information. Actually, vBond is sharing that information. So whatever information that vBond has, So vBond having the information, so you have your vBond here. It will share with vSmart and vManage as well. So actually all these controllers, they have information about all these devices, their serial number and chassis ID. If they do not have those communication, they will never form the tunnels. Okay. So they have the tunnels formed because they have the information about that. Now, once you go and connect our lab, so you can go and bookmark the devices. So let me quickly go and open vManage. Let me quickly log into that.
So vManage is still a Viptela based or
Viptela.
because I
V
haven't.
stands for Viptela.
Okay.
So whenever you are seeing this a small V here, this is actually Viptela. So
No, now
Viptela
they
man.
have changed is something Catalyst something.
Still we have vManage, vSmart, vBond. So Catalyst Center is there, but still the device name is same.
Okay.
Okay, so I will explain you what about this DTLS and TLS tunnel. So don't worry, but yeah, control connections that they are building. So better we should also go and check our own Canva that how they are building it. Meanwhile, let me see where we are. Okay, meanwhile, this is some distraction. Let me quickly go to that diagram where we are plotting that diagram. So here we are. What I have done, that this is my tool, that is the Obsidian tool. You can go and integrate this with drawing tool as well. This is Xcalidraw, where you have all these drawings and all. It can generate nice drawings, links and all those things. And then you can save everything here in this notes. So after the class, I'll share the notes. You have the notes. Okay, so why not let's quickly go and draw this. So let me do that quickly. So what I will do here is that, let me quickly remove this first of all. And this, click to interact. Let me quickly remove this. So what I try to tell here is this, that okay, you have this controller and this controller will go and name as a vSmart. vSmart is the intelligent behind the scene. It has all those brain that it can take the routing decision, forwarding decision. It can work as a IPsec key server. It can work as a BGP route reflector. You know, it has all those key things. You have vBond, and then you have suppose. Let me try this. DC1, VH1. It will remove this. Let me centralize this also. We manage vSmart bot. And then you have the branch. Almost there. So how our topology is that you have one data center DC, and then you have branch 1, and then you have branch 2, and in between that you have some ISP. So suppose ISP1, ISP2, actually assuming that one is MPLS and other is internet. And then obviously you have the connectivity, like physical connectivity, like this. And obviously the internet is connected with this. This is your DC data center. This is your branch 1 and this is your branch 2. And branch devices that we have, so they are something like, say, branch 1, C, C, H1, and then you have branch 1, CH2. And then finally, this is, say, branch 2, BR2, VH. So in our lab, we have VH1. Like that, we have the diagram. Now what I'll do, I'll quickly go here and do some color changes. So suppose the MPLS is red one, and suppose the internet is maybe green type. Okay, and then the connection. So now let's focus here on the control connection. So if I go and focus on the control connection, and let me use some different color. So the edge devices, they will go and pair with obviously the VS Smart. I should have some nice color here. Basic, actually the, anyway, this will work. So I will do one thing. Try to understand this logic here. I'm connected with MPLS, and then I am reaching to VS Smart. Then I am connected with internet, and then I am reaching to VS Smart. So to reach to VS Smart, I have two connections, control connections. Then for the C edge as well, the same thing. Reach here. So your control plane actually behind the scene in SD-WAN is your VS Smart. But but for the vManage, they will manage only one connection. Either it is MPLS or internet, we can force as well. But if you go and check the control connection with vManage, you will see that that is over only one circuit. Okay.
And how it will decide if we have multiple circuit, then on which circuit is gonna make connection?
That is default only, but we can force it to choose one circuit versus other circuit.
So default is what? MPLS.
That is good question. Default is how they will go and select the, why MPLS? They will never select MPLS. There is no need of
Yeah,
selecting MPLS. The default will be 100% your internet only.
direct.
Yeah,
Or it will
internet only.
see like what is the bandwidth and something. Because in direct internet, there will be a netting, right?
Yes. I will explain all this. Don't worry.
Mhm.
Check the connection. My internet is down. That's no worries. We have direct access, right? So let me quickly go to that vManage. And if you see the vManage, let's see here. Let me go to any of the device. Suppose if I go to DC1, VH1, devices, username, password, admin, and show control connections. See here, with VSmart, you have 4 connections, right? Like 2 VSmarts are there in this lab. So for one VSmart, you have 2 connections over internet and over uh, MPLS. But for vManage, I have 1 connection with MPLS. In our lab, just the name is MPLS. It's like internet MPLS, both are almost same. We have named it as a MPLS or internet circuit. But you're able to understand this logic to reach to
No,
actual
can you explain once again this one? How the control connection is building up.
you think like this, that who is your brain? Your VSmart, right? Now, obviously, to reach to your brain, that is nothing but your VSmart, you need multiple path, because VSmart has to take the decision of routing policy and uh, normal policy, like control policy, data policy, the IPsec tunnel policy, and all those things. But your vManage is what? Your vManage is something. Suppose if I have to go and manage 200 vManage sessions, is it required? No, right? We don't need to manage 200 connections with vManage. See, I this is control connection, right? It's not data plane connection like IPsec tunnel and all. But still, to manage the control connection, you need some bandwidth. Why you need bandwidth? To send control packets that I am live or not. How the devices will come to know that DTLS tunnel is up, TLS tunnel is up, because they are sending periodic hello packets, some DTLS packets that I'm live, my tunnel is up. Now, suppose if you have 2000 devices and 3 circuits, then 2000 into 3, that means 6000 connections we need to manage. So instead of peering with 3 different ISP, why not vManage should go and peer with only 1 circuit? What is the relation? Think like that. What is the relation in between the vManage and the edge devices? What's the relation?
He only sends control information to them.
What is the relation here?
There's no routing to be done through him, but he only sends control information.
Right. So you're right. So
He's
the
giving
relation,
the instruction, but that instruction will go to VSmart and VSmart will push those instruction to the VEdge.
Yeah, relation is netconf. That relation that we have is netconf. So vManage is using netconf protocol with port number 830. That's the SSH port number 830 to push the template. So from vManage, you will create the template and then you will push to edge devices. Right? So that's the relation. Now to maintain that relation, you don't need multiple connections. One connection is okay, that is active, the rest will work as a backup. So either vManage can communicate over MPLS link or internet link. Suppose if MPLS will go down, automatically you will see they are peering with internet. But with VSmart, because VSmart has other things also to do, later on you will come to know that they have something called OMP peer as well.
Yep.
Overlay management protocol. So OMP is which is sending, receiving continuous routing updates within OMP, right? So that devices, they have to go and manage their IPsec tunnels, their routing changes and all those things. For VSmart, because since this is your actual brain, you are maintaining the redundancy. So you have device level redundancy and you have ISP level redundancy. But that is not required with vManage. So why you will unnecessarily manage the extra circuits? That's why we have less number of circuits like control connections with vManage.
Okay, so here one thing. So vManage, we are pushing the templates and template is going using netconf to the VEdges.
To everyone,
Since
like not only
to
this. Here, generally, we are not managing that vSmart.
Okay, yes,
Everywhere.
this was my question.
Yeah.
That it should be placed to vSmart and other VBond as well.
Everywhere, the communication in between vManage and the devices are netconf. But the communication between vSmart and edge devices is OMP. It will come later, so don't worry, I'll cover that.
Okay.
Okay. So this is the overall architecture that we are going to work on. So next class, I will go and log into vManage and I'll follow the agenda. I'm person who is giving the agenda and following that. So I will go and follow that agenda. And even you can see this is the API that it is intelligent enough, this tool, that it is taking data services API control connection and it will go and even it will give me the control connection details as well. It has some security issues that it is bypassing now. Some different API it is using all those APIs and all. Just keep changing until unless it will get succeeded. Keep check that. Yeah, so it got that. Now this is the JSON format. Now it should give me the information in proper format that I can understand. So I will give this time, but it is fast. For device ID, so I don't have any device ID 10 10 10 or that is some vManage or something excellent. And it's doing more thing than I'm asking. So for this is vManage. For vManage, you can see that this is my question actually. That how many control connections we have. So it's giving me all the details. Even I haven't asked this thing, but still it is giving me these details. Is this useful details? Yeah, some see how things are happening, the operation task.
Yeah.
Okay, so amazing.
So,
1 second. I need to share you the notes, so that's why I'm sending to my notepad. Just give me one more minute. And we are very much done with the class. So let me quickly summarize this. So you can check the session as well. Let's go back here. And so what we studied today is that introduction and the component. That's it. That's 35-40 minutes on that. And then next class, we have some hands-on. Make sure that you have your Cisco AnyConnect with you. So that will help us. Apart from that, we are trying to
you
draw
wanna give access, right?
even Cisco AnyConnect. I requested Karen to install that. Yeah, I will provide you the details, but yes, you need that. It's okay. So let me quickly send that details, the notes that I created, and later on I will send it to you as well. So we are almost done for today's session.
Any connect means I need to use the same like group and or I should be getting different one, the cloud one.
Yeah, means I will provide you that username password. So don't worry about that.
No, the
And I will,
username password I have already, right? I
yeah,
think.
so for Cisco AnyConnect, so we are almost done. Let me quickly pause the recording.